periodic table, you're adding protons and electrons. The Q is bigger in both cases. That makes the atom smaller. Okay, does that make sense? Force of attraction is larger, the atom shrinks. Okay, cool? And that's generally the pattern. Smaller, 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 smaller. Now, as you go down the periodic table, the atoms get bigger. And Andrew, hang in there. 152, 186, 232, 248, 265. 71, 97, 110, 130, 141. Why does the atom get larger as we move down the periodic table? This one's super simple. Because more electrons, specifically more, you add a whole new shell. Yeah, you add a whole new electron shell. So as you move down, you add a whole new electron shell to the periodic table. Cool?
Yes.
All right. That's atomic radii, aka bigness. Ionization energy. Ionization energy is the energy it requires for us to remove an electron. Basically, how strongly the atom holds on to its electrons. Ionization energy is how strongly it holds on to its electrons. First of all, which atoms, remember the Pokemon, the Awesomemon idea we talked about?
Yeah.
If you've got all but one card in your set, what are you going to do? Try to get that last one. If you got a full set, what are you going to do? Hold on to it, right? If you got a couple extras, do we care about those extras? Not really. We're not going to just throw them away, but we're not going to hold on to them very tightly. So, that's how the periodic table works. What elements have the strongest ionization energy? Noble gases. Why? Because they've got their octet. Their octet is complete and they do not want to break it. Okay? So ionization energy is strongest with the noble gases because they've got their octet and they don't want to break it. Ionization energy is lowest with group 1 elements. Why?
Because they don't have an octet.
Not only do they not have an octet in their outer shell, they've got only 1 or 2 electrons. These have extras. Hey look, there's lithium, which I consider the most precious metal for the 21st century. Almost all of you have lithium in your pocket. What do we use lithium for in the 21st century? Batteries, yeah. And as our technology grows and grows, our use of lithium will get bigger and bigger until something replaces it. But lithium is great because it's got that one outer electron that's easy to move around. Makes it very good batteries. We would use sodium or potassium. The problem with sodium and potassium is they would make excellent batteries, but if you broke them in half, they would explode. So when lithium overheats, it just catches fire in your pocket in an airplane on a Samsung Note. If we made the battery out of sodium or potassium, it would explode. And we don't generally want phones that explode. Okay, so as we move across the periodic table, the ionization energy goes what? Up. Why? Because we are closer to an octet. Closer to an octet. As we move down the periodic table, what happens to ionization energy? 520, 496, 419, 403. It goes down. Why does the ionization energy go down as you go down the periodic table?
Adding of new shells.
Okay.
To have a weaker attraction.
What is holding the electrons in the atom? Protons. Okay? Well, if we go down, we have more protons and more electrons. The ratio is still 1 to 1. But the electrons are held weaker as you go down. Why?
Because they're
Yeah, but even with the noble gases, they get weaker as you go down. Why is the pull for the electrons on the for the electrons by the protons weaker as you go down the periodic table.
Because the electrons are getting farther and farther away as you're adding more shells.
Exactly. The electrons are further and further away. So because they're so far away, and there is a distance component to our force equation, because they're further and further away, the force is weaker on those outer electrons. Does that make sense? And there's something else called shielding, which I can teach you next year if you take chemistry AP, but right now, it's not important. So the most important thing is the trend is, as you get further away, the pull of the protons on those electrons gets weaker because they're further away. Capiche? Give me a thumbs up if you're ready to move on. The next trend is the single most important trend for the next year and 8 months. Year and 7 months. And that's electronegativity. Electronegativity is the strength an atom has to take an electron from another atom. Electronegativity is the strength that an atom has to take an electron from another atom. Again, electrons are the currency of atoms. Some are bigger bullies. There's ones that take lunch money and ones that freely give them up when asked. If you are attempting to collect your last Awesome Mon card, you're going to try really hard to get that last Awesome Mon card. If you've got a full set, you're going to hold on to it. Do you want any more once you've got a full set? No. That is why the periodic table doesn't show noble gases for electronegativity. You're like, hey, wait a minute. 1, 2, 3, 4, 5, the noble gases are missing. Yeah, the noble gases are missing because they've got their octet. Do they want any more electrons? No. So their electronegativity is effectually 0. What atom is the biggest bully in the periodic table? Fluorine. Fluorine has an electronegativity value of 4, the highest in the periodic table. Fluorine is able to take an electron away from anybody. If fluorine encounters boron, boron's like, I got 2 units of strength. And fluorine's like, I got 4 units of strength. Give me your electron. So fluorine is the biggest bully on the block. Nothing can pull an electron from fluorine, but fluorine can pull it from everybody. Does that make sense?
Yeah.
Okay. So that's electronegativity. As you move across the periodic table, as you get closer and closer to an octet, your electronegativity goes up, 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 until you get an octet and becomes 0. Hang in there, Andrew, you can do it. And for the same reason, as you go, as the previous trend, as you go down a periodic table, the electronegativity goes down, once again, because those protons are so far away from the outer electrons. Okay, does that make sense?
Yeah.
Okay, electronegativity is the single most important property for you to learn for the future. So much so that I'm going to have to reteach this to chemistry AP, because we were talking about, it's like, well, why is that? Like, because fluorine is more electronegative. And they're like, okay, I understand that, but what about chlorine? I'm like, it's close to fluorine. Really close, right? So, very strongly pulling electrons, not so much. Okay. Give me a thumbs up if that makes sense to you. Ionic radii. This is kind of fun. I'm not going to give you I'm going to give you the basic trend. All right. Opposites do what? Attract. Likes do what? Now, with an ionic radii, you are not adding a proton and an electron. You are only adding or removing a what? Electron. You're only adding or removing an electron. If you add an electron to an existing shell, which is how we make ions, 4p4 becomes 4p5, then 4p6. Okay. When you add an electron to an existing shell, what happens to that shell and why? Chat with your neighbor. With everything we've learned so far, you can probably convince your neighbor you're right. If you add an electron, let's say you add a 4p6 to a 4p5. You add one electron, turn a 4p5 to a 4p6. What happens to the orbital that electron is in, and why? So chat with your neighbor, take 30 seconds. All right. Your options are embiggens, lessenizes, or samifies. So if you believe that the orbital embiggens, raise your hand. If you believe your orbital lessenizes, raise your hand. And if you believe it samifies, raise your hand. It embiggens. Okay? It embiggens because when you add electrons to an orbital, what do those electrons do?
They repel.
They repel, and the electrons will swell. So, or the shells will swell. So, ionic radii is the attraction of protons and electrons, but now we're adding or removing electrons. Which is why, if you add an electron to an existing atom and form a negative ion, it's called an anion. And an anion will always be larger than its original atom. Okay. By adding an electron, an anion will always, to an original atom, the anion will always become larger. And the opposite's also true for one more reason. So the original reason works too. If you remove an electron from an atom, you form what's called a cation, and a cation will always be smaller than its original atom. For one additional reason. In addition to removing an electron, and now there's less electron-electron repulsion. That's a very sciencey phrase, electron-electron repulsion. When you add an electron, there's more electron-electron repulsion. When you remove an electron, there's less electron-electron repulsion. That's one of the reasons cations are always smaller. But there's another one. If you take away an electron from sodium, what have you done to the third shell? Sodium's electron configuration ends 3s1. If you take that electron away and form a +1 sodium ion, what have you done to that shell? You've removed it entirely. So you've shaved off an entire shell. So there's shell 3, and you take away an electron, you've shaved off the entire outside shell. It's gone. Okay? So not only is there less electron-electron repulsion, when you remove electrons, sometimes you eliminate the entire shell. Make sense? So anions add electrons, they're always bigger. Cations remove electrons, they're always smaller. If this idea makes sense to you, give me a thumbs up. Okay. We're almost done with this concept. I just want to make sure that this resonates with you. So, by the way, this is called anion and cation. If you call it cation, I'll be like, but other people might be less forgiving. They're like, no, it's a cation. Don't say it wrong. Oh, okay. But it's cation. Okay. If you have questions, wave your hand around. Okay. So we're going to wrap up our discussion tomorrow, obviously. We're talking about groups and their properties. And there's a bunch of them that we label. I'm going to give you the overall, and then we're going to hit each group one at a time. So you don't need to write this down. We're going to look at each group in detail tomorrow. But, okay, so don't need to write down the names of the groups just yet. I want to talk about the charges in a second, and then tomorrow we'll go over each group individually. Oxidation, this is something you should write down. Oxidation is the name of the charge an ion has. Okay. It's the name of the charge. And oxidation can be anywhere from -7 to +7. Doesn't usually be -7. In this class, it's going to be -4 to +7. We're not going to look at lots of crazy exceptions. So we did this last week with a little green dot. So let's do it again. Only now we're going to use this board right here. So before we use that board over here, now we're going to use this one. So group 1 has how many outer electrons? 1. So group 1 wants to do what with that outer electron? Lose it. So what charge do you become when you lose one electron? +1. Group 2, I know you're wrapping up, but it's just relax, try not to make too much noise. Group 2 has how many outer electrons? 2. What does group 2 want to do with them?
Get rid of them.
Get rid of them, forming what ion charge?
Plus 2.
+2. Okay. Noble gases, how many outer electrons? 8. Do they want to do anything? No. So what's going to be their charge? 0. Fluorine's group, how many outer electrons? 7. What does it want to do? Get one more, and if you get one more, your charge is -1. Oxygen's group, how many electrons? 6. What do you want to do? Gain 2 more. If you gain 2 more, your charge will be -2. I love the front 2 rows. Like A minus B, C, D. Maybe B, C. We'll see. So the pattern is this: +1, -1. What's boron's group? Oh, sorry, +1, +2. Yeah, +1, +2. Boron's group will be +3. Carbon's group is +4 or -4. It is an equal amount of work to gain 4 or lose 4. Nitrogen's group, oxygen's group, fluorine's group, -1. And this is the name of the groups. Maybe they're going to come up. There we go. First group is called the alkaline metals. Again, we're going to look at them individually, one by one, tomorrow. Alkaline metals, alkaline earth metals. The big block in the middle is called the transition metals. The main block elements, E blocks are main block. A subset of the main group is halogens, and then noble gases, and then these guys down here are the rare earth elements. Yeah, the halogens are ones that we rub on your skin to kill bacteria, or dump in the pool to kill bacteria. All right, questions? Cool. Press the button. The little shiny one.